you?
Good, welcome to Pikes Peak.
Ralph, thank you so much for joining us today. I was really hoping that you could take us through the new building in the order that we'd actually do product development, so Cornelia could really see the benefits of how the new building is adding value to our process.
Sure, in that case, let's start in the UX testing lab. So at Hach, our vision is to make water analysis better, faster, simpler, and more informative. So we start in our user experience testing lab to understand our customers' pain points, their workflows, the way they do things.
There's instructions here that you can each use, but just work together and just tell us your thoughts as you go.
This is the UX usability lab, and it's kind of a historical first for Hach because before we didn't have a place to recreate the environment for our users. So we can now bring our users here at Hach and kind of test any of our concepts that we develop here, whether it's software or hardware or firmware. And we'll do various levels of fidelity with that. So we can test everything from a piece of paper, hey, you know, what do you think, you know, between this and this, which would you go for on a really high level? Or we can even get down to testing software and prototyping it on tablets and computers, all the way down to actual products that we have, you know, before we actually release it.
I'm more of a white bread fan on peanut butter and jelly sandwiches.
And even after that, we can take it in and take a look at what does the first time unboxing look like for our users? How does this manual work for this new device we've just created? So that magic can happen in this space. And so we have a two-way mirror as well. So again, like I said, the idea is that we can kind of recreate the environment of our users as much as possible so that we can get a better feel of like, are we really solving the problems for them? Do they really have a need for what we're making before we spend a lot of money making it? So being able to have that opportunity to do that in the space is awesome. It's a first for Hach, and a lot of companies don't have this privilege, so it's really great.
Once we understand the user needs from our user experience lab, we come here to the Obeya. Obeya is just Japanese for a large room, and that's the area where the whole cross-functional team, including our product management, our service, our manufacturing, we all come together and come up with the ideas that we're gonna have for our product. We also have all of our visual management here in the same space. So here's how we know what we're doing and how we're going to evaluate it based on those same user needs. Okay, here in our build test area, we take the ideas that we came up with as a cross-functional team and we build models. And we start with quick models so that we can test them over here in our test area and learn quickly. The idea being that the more iterations that we can build and test, the more we're going to learn. If we learn a little bit each time, we're going to get much better products. To do all this, we need to be able to build these things quickly, and that's where our model shop really comes in.
With the new building, we doubled our floor space coming over here, which is going to enable us to have new equipment, which we've already purchased. We have a new CNC lathe, which we purchased, had delivered to this facility, which is going to increase our productivity with all our turn parts, machine parts. We have room in this space for 2 new 3D printers, which will allow us to turn prototypes quicker and more of them for testing in multiple levels in the Obeya space. With the 3D printers, we can make 20 of something and it can go to a software group, it can go to an engineering group, or they can have multiple iterations immediately. They can sort through what works, what doesn't. We can turn another model the next day within 24 hours. So it just enables the whole process to be sped up, more parts in their hands quicker, less labor on our end because the machines are generating the parts.
Okay, once we've built our product in the Obeya with the parts from the model shop, we need to do some higher fidelity testing to make sure our products really meet their specifications. The first stop is our electromagnetic compatibility, or EMC testing. This is where we look at the radio frequency emissions, or RF emissions, from our products.
In this lab, what we do is we measure the output of our products so that we can make sure that we comply with international standards. The products output an RF noise level, and the RF noise level is then transmitted and collected by the antenna mast that's over on the back half of the room. That information is then collected, transmitted to our control room, and measured against those standards to make sure that it's below the level necessary for us to ship our product. As products get larger in volume, physical size, it requires more size within your anechoic chamber. This is an anechoic chamber, and what that means is there's ferrite lined on the walls, which blocks all the signals from coming in, so it's a pure environment where we can measure purely what's coming off of our products. By being able to measure at a high level of accuracy the output from our device, what we ensure that our devices will not have any unintended consequences or negative side effects with other products that are on the market, whether they're Hach devices or whether they're traditional devices that go into the industrial and the municipal market spaces. By having this facility, it gives us the unique ability to control our own ability to deliver unique and differentiated products to our customers, so we're not dependent upon somebody else to fit us into their schedule and to get that compliance level and to get that certification. So we truly are vertically integrated here at this facility in Loveland to support accelerated development.
EMC is only some of the testing we need to do. We also need to do safety testing to make sure that our products are safe for our users.
Safety compliance standards play a very important role in all our development and sustaining projects. Fulfilling safety standards and regulations allow us not just selling products around the world, but guarantee that our instruments are reliable and robust, and the most important, our customers are safe using them. Thanks to the new safety laboratory, we will increase our testing capacity. With a bigger and fully dedicated area, we can have the different test stands and even the chambers placed in a lean mode, and we will be able to duplicate the stands. This will permit us to evaluate 2 products in parallel.
All right, we have one more critical test area to show you today, and that's where we do our Ingress protection, or IP, or our enclosure rating testing to the NEMA standard, which is the National Enclosure Manufacturers Association.
This is where we actually test our equipment for its resistance to water intrusion. We do this in a couple of different ways. One, we use the chamber to my left to test for water intrusion using a fire hose. We actually take our equipment, set it at the end of the chamber, and hose it down as thoroughly as possible. This allows us to see if our equipment will stand up to external environments like rainstorms and things like that. In the past, we had to tie into the building's fire suppression system and do this testing outdoors. This often led to more of an impact test than an actual water test, because 6 months out of the year, it's a little bit chilly here in Colorado. Also in this facility, we can do our IP testing. This allows us to actually dunk our equipment underwater for an extended period of time. This simulates what happens when our customers occasionally drop our equipment into the lake and it ends up on the bottom. This testing can be done early in the development process, allowing us to make key developmental decisions in the design process early, rather than waiting until we have production representative tooling and hardware.
All right, now that we've seen how we understand what our users need, and then how we design, build, and test our instruments, and how we further test them with some specialized testing to really make sure that they're ready for our users, we've forgotten one minor thing. A lot of our instruments really need chemistry. So we have our synthesis lab here, and one of the key things that this lab does is lets us bridge the gap between the development scale and the production scale for our chemistries.
When you compare it to the previous lab that we were in, we were able to do reactions on a 1 liter scale for new chemistry development. And when it came time to do a handoff to our Ames, Iowa team for scale up, it was a little bit messy because we didn't have any of the kinks worked out when it came time to scale up. They had to not only move environments, but also go from a 1 liter to a 20 liter to, 50, 500 liter, very, very large scale chemistry. So they had to troubleshoot not only moving to a new environment, but also how does the chemistry change? And so now that we are in the new building, it's really exciting because Ames has a 20 liter synthesis area, and now we do too with the synthesis lab. So when it comes time to making a chemistry, I can make it on a 1 liter scale here. I can make it on the 20 liter scale then, and then hand it off to Ames. So when we say that we're going to come out with a new product, and this is our deadline, we're most likely going to better meet that deadline or have an idea when it leaves my hands to go to Ames, it should be a fairly smooth transition.
Well, Karen and Cornelia, that finishes our tour. I'm sure you can see that these amazing new facilities are going to help us get even better at delivering great products that really meet our users' needs.